Yes. So, Spherical students, let's have lecture number 1, class 10, reflection and refraction. So, in this lecture, we are going to learn the basic terms in case of spherical mirrors. Students, when we talk about reflection, there must be a surface from where the reflection of light rays is done. Now, the surfaces which we are going to study more, which have wide application in our day-to-day life for the image formation, is number 1, spherical surface. We talk about spherical mirrors, and we talk about lenses. So let's understand. Now, when we talk about spherical mirror, imagine students that we are having a sphere. Though I am drawing a circle, but you think of this as a sphere, right, students? So this sphere will be having its own center. Am I right? You see, the sphere is 3D object. It's not 2D object. The circle is a 2D object, right? Just like a football or a ball, ice ball. They're all spheres. So what I do, I cut a small portion anywhere on the surface of the sphere. Let's say I cut a small portion of the sphere. Okay, students. So another question is, this portion will not be plane. It will be spherical, means it will have a surface inside and it will have a surface which is bulging outside, right? If I cut this small portion from the sphere. Now students, imagine that this is a hollow sphere made up of glass. Now this cut portion, circular in shape, this cut portion, what you get is exactly spherical mirror. But it has both the surfaces, reflecting, means this surface which we can see from outside, and this internal surface which we are not able to see. But when we take it out, we are able to see both the surfaces. Let's say we polish one surface, right? Then it becomes a spherical mirror. First, we take two pieces. One piece we polish from outside, right? So it would be like this. The outside bulging portion is painted. Let's say we paint this, when we paint this, you must have seen mirrors. One side is painted. Let's say one side is painted and internal side is, the reflecting surface. Now students, honestly speaking, it is the reflecting surface, the shape of reflecting surface, which decides which type of spherical mirror is this. In case in case of first one, in case the outer surface of this portion is painted, right? So say either you say it's painted or you say this is shaded. And inside surface, which is going inside, is the reflecting surface. Maybe a light ray comes after striking here, it will get, reflected. So this kind of mirror with one reflecting surface and one surface which is painted, right? Which is making it concave mirror, right? So in case of concave mirror, the reflecting surface is going inside, it's going inside. Reflecting surface is going inside, right? See students, in every mirror, one surface is going inside and one surface is bulging outside. But it is the reflecting surface, the shape of reflecting surface, which decides whether a mirror is concave mirror or convex mirror. Now students, we have taken the second mirror also, no? The second portion also we have cut, imagine, from this sphere, right? So now what we do, it has one surface, this surface which we are able to see is bulging outside, right? And other surface inside surface will be like this. Let us say we paint that surface. We paint this surface. One second, let me draw it again. Now I'm going to explain what is convex mirror. So I'm talking about this case. Let's say it's like this, right? The inner portion I am painting, or in other words, you can say it is shaded. This is shaded area. Or you say this is painted, and other surface I'm leaving like this. It's glass, so it will be, you can say this is a polished surface. This is a surface where the rays will be, reflected. So imagine in a very strange way, here the rays will be getting reflected, means if a ray comes, and it will get reflected in this way. Obviously, it cannot enter because of this shaded area. Other portion is painted. So the ray will come. This is incident ray, and this will get reflected. Now, this kind of mirror is known as convex mirror. So it's very clear to us, in case of convex mirror, the bulging surface, the surface which is bulging out, is the reflecting surface. In case of concave mirror, the bulging surface is painted, is the shaded surface, and the other surface which is going inside is the reflecting surface, is known as concave mirror. All right, students, having understood what is a concave mirror and convex mirror, right, you can also understand, if this is a spoon, right students, here, this is probably a spoon, right? The spoon is having, if you see, it has one surface like this, going inside. So imagine this spoon is not made up of steel, it's made up of glass. The portion normally which touches the inner portion of our cheeks is painted, then this becomes concave mirror. In case the portion which is going inside, is we are painting, and we remove this portion, and the other portion which is bulging out becomes the reflecting surface, then this spoon represents a convex mirror. So having understood convex and concave mirror, students, now we define few important things. For this, again, this hollow sphere is there. Don't forget about this. Now, students, this hollow sphere is there. This hollow sphere must be having some center. Am I right, students? This hollow sphere must be having some center. Now, this center of the sphere, from which I have taken a small spherical mirror. I have cut a small spherical mirror. This point of the, so in other words, you can say, students, this spherical mirror, if I extend if I extend all the sides of this spherical mirror, it becomes a sphere. The center of the sphere is known as center of curvature, normally represented by C of a mirror. In simple words, what is center of curvature of a mirror, of a spherical mirror? You can say if a spherical mirror is small like this, if you extend this, it will become a sphere, hollow sphere, right? The center of that sphere will be the center of curvature. All right, students, having done this, the second point is the, focal length. Focal length of mirror. What is focal length of mirror? This is represented by F. You see, center of curvature is a point, but focal length is having units in meter or centimeter. It's a distance. What is focal length of a mirror? Imagine, students, you are having a concave mirror. Am I right? Concave mirror means, as we have already studied, this the portion which is bulging out is polished, or this is the shaded area. In the right now, students, here I talk something about principal axis. What is that? This is the principal axis of the mirror. Am I right? Principal axis of the mirror, students, remember, passes through this point, which is the center of the mirror. See, the center of the sphere, center of extended spherical mirror was center of curvature, which is the center of the sphere. But I'm talking about center of the mirror. Means if this is a small mirror, I'm talking about its center. This is known as pole. Okay, one more definition. See, we should have done it first, but it's okay. Pole. It's also a point, just like center of curvature. Pole is represented as P. Okay, students. So this point is P, right? This point is P, and a line which is passing through the pole is known as principal axis. Principal axis of the mirror. On this principal axis, students, see very carefully, in case there are some rays, in case, what did I say? In case some rays are there which are parallel to the principal axis, very important. Some rays are coming from infinity, which are parallel to the principal axis. All these rays which are coming from the infinity, which are parallel to the principal axis, all these rays will, after striking the mirror, students, they will pass through one point. All the rays will pass through same point. They will be reflected back through the same point. This point is known as F, focal point. What is this point known as? This point is known as focal point. Focal point we can represent as F. Okay, focal point. One more thing. Focal point, or simply we say focus. Or we can also say principal focus, since it's line 1, principal axis, focus. Okay, focal point or focus. See, students, you have seen it's represented by F, P, C. All these are points. These are not lengths. But focal length represented by small f is a length, and it is equal to FP. You can see here it is equal to FP. And what is FP? FP is the distance between any student. Yes, hope you are understanding. Can you tell Monrose? Focal length will be the distance between which point and which point? It is the distance between, yes, what is
F
F?
and P.
F and P. What is F? F is focus and P is the pole of the mirror. Distance between pole of the mirror and principal focus F is known as focal length. This length is known as FOCAL, focal length. It is represented by capital R. It is represented by capital R. Okay, students. Now, you have seen this mirror. This mirror you have taken out from a hollow sphere, which is made up of glass. You know, this is the reflecting area of the mirror. Am I right, students? Either this side or the other side, depending upon which kind of mirror it is, you know. This is the reflecting area of the mirror. This diameter of the reflecting area is known as aperture. A-P-E-R-T-U-R-E, aperture. Okay. Now, for small aperture mirrors, means for mirrors having small reflecting areas, for small aperture mirrors, all right, students. So focal point is F, aperture. For small aperture mirrors, students, for small aperture mirrors, remember, I'm going to state something, but before that, we are going to see where is the C. Students, this is FP. FP means F, focal length. If I take double of focal length, I will get one more point A equal to FP. I will get one more point A. This will be C. This will be the center of the sphere I was talking about. Okay, that is center of curvature. C. So F will be in between C and P. Remember that F will be exactly in the center. Only this case is applicable for small aperture mirrors. What do we want to say? That means for small aperture mirrors, the focal length F would be equal to half of what? Focal length F. This is also F. This is also F. This will be half of distance between point center of curvature and pole of the mirror. So I can say F is equal to half of CP, right? Very, very important, students, that F is equal to CP by 2, or you can say CP. CP is known as radius of curvature. Yes, Monrose, please repeat. What is CP?
CP is radius of curvature.
Beautiful, beautiful. CP is radius of curvature. And may I please know what is radius of curvature? It is the distance between C. What is C? Center of curvature. And what is P? P is the pole of the mirror. See, students, one more interesting thing. Pole of the mirror lies on the mirror. But see, center of curvature of the mirror does not lie on the mirror. Am I right? Because this mirror we have taken out from the circumference of the circle. And inside that, there will be one center of the sphere, which is known as center of curvature. So students, these were very important aspects or definitions related to a mirror. And the same definitions are related to convex mirror and concave mirror also. Okay. One is center of curvature center of the sphere from which we have taken out the spherical mirror. Focal length, what is focal length? Focal length can be measured in meter or centimeter. It is the point at which, can anyone say? See, these are all incident rays, IRs. These are coming from infinity. Very simple, students. If a point is at, if an object is at infinity, all the rays which are coming from that object will appear to be parallel, right? You can apply this logic how? If these 2 points we are able to see from here, angle is this. If we go here, the angle is decreased. If we go here, the angle is further decreased. And if we go to infinity, we will see these 2 objects. This distance will be irrelevant. We will see that these rays are parallel. That's a reason. From a point object, from object at infinity, the rays which are coming will appear to be parallel. And rays which are parallel to principal axis, they will all pass through. Any student? All these incident rays will pass through. Come on, students. Anyone? After getting reflected, these are incident rays, and these are reflected rays. They will pass through focus, right? Then pole, we have taken out. You can take mirror from anywhere. The center of this is the pole, but the center of extended mirror, the sphere, is the center of curvature. Then focal point, distance between F and P, aperture, reflecting area of the mirror, that diameter. Diameter is the aperture, pole, everything we have done. For small aperture mirror, F is equal to Cp by 2. Once this lecture is clear to you, you revise it 2-3 times, write down all the definitions, then other lectures will not only be interesting, but you will be able to understand very easily. Thank you very much, students.